Hi guys, today we'll discuss about your random access protocol, carrier sense multiple access. In last video we have been discussed about your Alaga protocol, two types of Alaga protocol, PU Alaga and Slaughter Alaga. Now we'll discuss about CSMA. In last video we have been discussed what are the three classes of MAC protocol. One is fixed assignment, demand, random access protocol. So under this random access we have four different type of protocol. One is Alaga, CSMA carrier reduction and CSMA carrier collision. So today we'll discuss about carrier sense multiple access. So carrier sense multiple access means whenever we need to transmit our data, what happened before that we have to sense our channel. Okay, so we have to listen to the media and this is called as carrier sensing. So when a media or a channel is ideal, the node can transmit its information. Suppose if a media is busy, okay, what happens? The node should not transmit any of your packets. So you have to wait for a random amount of time or a few amount of time. Okay, after the time you have to sense your channel. If it is free, you can transmit. So what happened? This carrier sense protocol will lead to a problem which is called as hidden terminal problem. So this hidden terminal problem will interface at the receiver and cannot be detected by the transmitter. So this problem may cause your packet collision. So to avoid this hidden terminal problem, the solution will be your RTS as well as CTS handshaking. That is request to send and clear to send handshaking. So this will be used in IEEE 802.11 wireless LAN. This will be based on your multiple access with collision avoidance for wireless protocol, and this will use only a single channel and there will be a two special control packet. So now we'll discuss about what is RTS or CTS handshaking method to avoid a hidden terminal problem. So we have been considered four different stations A, B, C and D. Now a node B want to transmit a packet to your C. Okay, node B want to transmit a packet to your C. What your B will do, B will obtain its channel access and will send a request to send packet to your C. Okay, so inside this RTS frame, what it's going to have, it's going to include the duration field will indicate the remaining length of your overall transmission. So what will be the transmission time? All those things will be included in this RTS frame. So this RTS frame will be sent to your C node. And the same time, this B will send this RTS frame to its neighbor to A also. Okay, so it need to transmit only, we are going to transmit information between B and C. So to avoid a hidden node problem, first you are going to send your RTS frame to its C. At the same time, your B will going to send it to its neighbor of A. Okay, now what happens? Your A will receive this RTS frame. As we know, this inside this RTS frame going to include the what will be the time period for the particular transaction. Yes. So once those information is received by the station A, that is your RTS packet, this will set a time interval. This will going to set a time interval which is called as network allocation vector, NAV. So during this particular time period, what happened? The node A will not go for your carrier sensing or not able to transmit any frame inside the media. Okay, so it will be remains a silent mode. It will be like a silent. Okay, so when the NAV get expired, okay, when get expired, what happens? Now this particular node can go for a carrier sensing. If your channel is free, it can able to transmit. So by doing this, what happened? We can able to avoid that hidden node problem. So now what happened? After getting this RTS frame from B, A will set as NAV allocation vector. So now A will not go for what? Carrier sensing until NAV get expired. Now what happened? C is received this RTS frame. Now your C will send a clear to send packet to its B. Okay, and this CTS also will again going to contain the duration frame and this will send back to your B. Now after sending to B, what happened? Your C will send this CTS frame to its neighbor also D. Now what happened? D will set this time interval which is called as network allocation vector. Okay, so network allocation is vector is set. Now what happened? The channel is busy. It is indicating that that channel is busy now, some other station is transmitting. So after setting this, D will be in a silent mode. Now what happens? Here B received the CTS frame. Now B will transmit a packet to its C. So after getting the information by C, what happens? Your C will send an acknowledgement. Okay, if your proper data have been received, your C will send an acknowledgement back to your B. And this will avoid this RTS and CTS handshaking method is used to avoid a hidden node problem in your CSMA protocol. Thank you.